Section 12.3, Inscribed Angles. Recall from a previous section, we have central angles of a circle. A central angle of a circle is an angle that has its vertex at the center of the circle. On this slide, we have inscribed angles. An inscribed angle of a circle is an angle whose vertex is on the circle and its sides are chords. In the diagram, I have angle YXW. The vertex of the angle is on the circle, therefore YXW is an inscribed angle of circle P. When I have an inscribed angle, it intercepts an arc, and in this case it intercepts arc YW. YW is therefore an intercepted arc of the inscribed angle YXW. In each diagram, identify the inscribed angle and its intercepted arc. On the first diagram, the inscribed angle is ABC, and its intercepted arc is arc CA. In the next diagram, the inscribed angle is SRT, and the intercepted arc is arc ST. Theorem 12.9, Inscribed Angle Theorem. The measure of an inscribed angle is half the measure of its intercepted arc. In circle P, I have an inscribed angle WXY. Its intercepted arc is YW. And from Theorem 12.9, I know the measure of angle X must equal half the measure of its intercepted arc, in this case YW. If the measure of arc YW is 60 degrees, then its inscribed angle would be half that measure, or 30 degrees. Corollaries to the inscribed angle theorem. The first one, two inscribed angles that intercept the same arc are congruent. Here I have an inscribed angle SUT. Its chords are in red. And I also have an inscribed angle SRT. Both of these intercept an arc ST. Therefore, if arc ST would be 80 degrees, then the measure of the inscribed angle SUT would be 40 degrees, and the other inscribed angle SRT would also be 40 degrees. Therefore, if two inscribed angles intercept the same arc, they would be congruent. The next corollary to the inscribed angle theorem is an angle inscribed in a semicircle is a right angle. Here I have a diagram and I have an inscribed angle ACB. Its chords extend to the endpoints of the diameter. Therefore, I know that the arc ADB is a semicircle, 180 degrees. And by the inscribed angle theorem, I know the measure of the inscribed angle is half the measure of the intercepted arc. In this case, a semicircle. Therefore, my inscribed angle would be 90 degrees. And the last corollary to the inscribed angle theorem, the opposite angles of a quadrilateral inscribed in a circle are supplementary. Therefore, I have circle P, and I have arcs. The last corollary to the inscribed angle theorem, the opposite angles of a quadrilateral inscribed in a circle are supplementary. Here I have circle P and a quadrilateral ACBD inscribed in circle P. We know that the measures of the central angles sum is 360 in a circle. Therefore, I can find the measure of arc DB. 60 plus 80 is 140. 140 plus 150 is 290, leaving the measure of arc DB when I subtract from 360 to be 70 degrees. Now I can determine the measures of the inscribed angles. The inscribed angle of ACD is equal to half the measure of its intercepted arc ADB. 60 plus 70 is 130. Half of 130 is 65 degrees. Using corollary 3, I know that the measure of angle D must be supplementary to angle C, which is 65 degrees. So angle D must measure 115 degrees. Let's verify that by using the inscribed angle theorem. The inscribed angle ADB has an intercepted arc ACB. The measure of ACB is 80 plus 150, which is going to be 230. Half of 230 is 115 degrees. The inscribed angle CAD has an intercepted arc DBC. And the measure of DBC is the sum of 150 and 70, or 220. So the measure of its inscribed angle is going to be 110 degrees. From corollary 3, I know that angle B must be supplementary to angle A. Therefore, this should be 70 degrees. We can verify that by the inscribed angle theorem. The inscribed angle CBD has an intercepted arc CAD. And the measure of CAD is 80 plus 60, which is 140, and half of 140 is 70 degrees. And that verifies corollary 3 to the inscribed angle theorem. For these examples, they want me to find the value of each variable in the diagram. My first example, I have an inscribed quadrilateral in the circle. I know the measure of this intercepted arc, and it represents the value of x degrees. And that is an inscribed angle. Therefore, it's half the measure of its intercepted arc, which makes this 60 degrees. This inscribed angle intercepts a diameter, which means its intercepted arc is a semicircle, which I know is 180 degrees. That makes this inscribed angle 90 degrees. And I know from corollary 3, its opposite angle is supplementary to that. So that is also 90 degrees. Using the triangle sum theorem in this triangle, I can determine the measure of this angle. 90 and 60 is 150. That leaves me 30 degrees. I know the value of this intercepted arc. Therefore, I can determine its inscribed angle, which is half the measure of that arc. So I know that this is 34 degrees. By using the triangle sum theorem, I can find the value of this angle. 90 and 34 is 124. When I subtract from 180, that leaves me 56 degrees. The next diagram, I'm given an inscribed angle and also a central angle. I know from previous sections the central angle is equal to its intercepted arc. Therefore, this is 88 degrees. And by the inscribed angle theorem, I know this has to be half its intercepted arc, which is 44 degrees. In this diagram, I'm given a central angle and an inscribed angle. I can determine the value of this arc because the inscribed angle is 51 degrees. When I multiply that by 2, that gives me the measure of its intercepted arc, which is 102 degrees. And I know the central angle is equal to its intercepted arc, which makes this also 102 degrees. On my next diagram, I have two inscribed angles that intercept the same arc. Therefore, they have to be congruent. Since I know their intercepted arc is 48 degrees, each of these must be 24 degrees. In this example, I have an inscribed quadrilateral in a circle. I can determine inscribed angle measures if I know the measures of their intercepted arcs. Here I can determine the value of this inscribed angle because its intercepted arc is the sum of these two arcs. The sum of those two arcs is 66 and 112, which is 178. And the measure of the inscribed angle is half of 178, which is 89 degrees. And from corollary 3, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Since this is 89, its opposite angle must be 91 degrees. I can determine the value of this angle because I know it has an intercepted arc of the sum of these two arcs. 112 and 102 is 214 degrees. Therefore, this has to be 107 degrees. Again, from corollary 3, I know that the opposite angles must be supplementary. 180 minus 107 leaves me 73 degrees. Theorem 12.10. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. In circle P, I have a chord AB and a tangent to that chord. That creates an intercepted arc ADB. And by theorem 12.10, the measure of this angle is half the measure of that arc ADB. If I know that the angle measure here is 58 degrees, then the arc must be double that measure. So the measure of arc ADB must be 116 degrees. In this example, again, I have a chord and a tangent drawn to the endpoint of that chord. That creates an intercepted arc, here ACB. And by theorem 1210, the measure of this angle must be half the measure of its intercepted arc. Since the intercepted arc has a measure of 240 degrees, the measure of this angle must be 120 degrees. On these examples, find the value of each variable. If the ray looks tangent to the circle, then assume that it is tangent. On our first diagram, I am given an inscribed angle and also a central angle that intercept the same arc. I know that a central angle is equal to its intercepted arc, so the measure of this angle is 60 degrees. I know the measure of its inscribed angle is half that measure, so this has to be 30 degrees. I know that this is a diameter, therefore that forms an arc that is a semicircle. And I know that this is 60 degrees. The remaining part of this arc has to be 120 degrees. This is tangent to the chord. And from theorem 1210, I know that it is half its intercepted arc, which makes this angle 60 degrees. Now I have a central angle that intercepts this arc. And I know the central angle is equal to the measure of its intercepted arc, which makes this 120 degrees. In this diagram, I'm given a diameter. That makes this arc 180 degrees. 180 minus 48 gives me this arc to equal 132 degrees. This is a tangent to the endpoint of this chord. That creates an intercepted arc. The measure of this angle is equal to half the measure of its intercepted arc. Half of 132 is 66 degrees. This arc has a measure of 48 degrees. I know that the half of its measure is 24, and that will equal the measure of its inscribed angle. So this is 24 degrees. The measure of this arc is 180, because its endpoints are on the diameter. The measure of this arc is 110, so the measure of this arc is 180 minus 110, which is 70 degrees. I know that this is an inscribed angle, and its intercepted arc has a measure of 70 degrees. And the inscribed angle is half that measure, which makes this 35 degrees. This entire inscribed angle intercepts an arc at the diameter. So I know the whole angle is 90 degrees. Since the measure of this is 35 degrees, this angle is complementary to that angle. So that has a value of 55 degrees. In my next example, I have a central angle that equals 104 degrees. I know the measure of its intercepted arc is equal to the measure of that central angle. So this arc must be 104 degrees. I have three arcs that make up this circle. I know the value of two of them. I know the sum of those arcs must be 360. 104 plus 80 is 184 minus 360 leaves me the value of this arc to equal 176 degrees. This is a tangent ray to this chord. That creates an intercepted arc, and the measure of this angle is half the intercepted arc. Half of 176 is 88 degrees. This inscribed angle has an intercepted arc with a measure of 104 degrees. The inscribed angle is half that measure, so this must be 52 degrees. In this example, they want me to find the indicated measure of the arcs and angles in circle P. The easiest way to do this is to actually find the arcs and angles of circle P independently of looking at the questions. After we find the arcs and angles, then I can go back and answer those questions. In the diagram, I know that BD is a diameter. I know that AD has a measure of 106 degrees. Since this arc is 106, I know the semicircle BAD is 180. Therefore, 180 minus 106 makes this arc 74 degrees. BD is a diameter. On the other semicircle, I know that arc CD is 150 degrees. Therefore, arc BC has to be 30 degrees. Given that arc AB is 74 degrees, I know that angle BCA is an inscribed angle of that intercepted arc. Therefore, the measure of that angle is half of 74 degrees. Therefore, that would be 37 degrees. Angle CBD is also an inscribed angle, and its intercepted arc is CD with a measure of 150 degrees. Therefore, angle B is half of that measure, which makes this 75 degrees. Now that I have a triangle inside my circle, I know the sum of the measure of those angles is 180 degrees. Using the triangle sum theorem, 75 and 35 is 112. 112 from 180 is going to leave me 68 degrees. By the vertical angle theorem, this is 68 degrees. Also, the intercepted arc to BA is angle BDA, which has to be half that measure, which is 37 degrees. And we notice angle C and angle D are congruent because they intercept the same arc. Since this is true, this angle has to be similar to this triangle, which makes this 75 degrees, which angle A and angle B intercept the same arc, which is 150, which does make those angles congruent. The only thing left is the tangent BE, which intersects the endpoint of my chord. That creates an intercepted arc BC, which we know is 30 degrees. Therefore, the angle EBC has to be half that, which is 15 degrees. Knowing the information that we've just solved in the diagram, we can now go back and answer the questions. What is the measure of arc AB? 74 degrees. What is the measure of angle BCF? Here we have BCF. We know that's 37 degrees. The measure of arc BC. BC we found to be 30 degrees. The measure of angle AFD. AFD is 68 degrees. The measure of angle EBC. EBC is 15 degrees. And angle BDA. BDA is 37 degrees.